So this is a class talking about interest. What is interest? What is interest? Can you tell me in your own words? What is interest? Yes, sir.
It's like
An added amount over a period of time. An added amount to what?
It depends on the rate.
It would depend on the rate and what else?
And like what you started with.
What you started with. Okay. So what you started with is known as the principal. And the rate is defined ahead of time. That rate could be a simple interest rate or a compound interest rate. What is simple interest? Can you tell me in your own words? I just want to know what you know already. What is simple interest? What is this thing called simple interest? Let's say my simple interest rate is 5%. And let's say I start with $100 principal. So I deposit $100 into my account, and it is to earn a simple interest rate of 5%. What would you have in your account at the end of year one? Yes? Okay. So at the end of year one, I have $105. Here it is. Okay. So simple interest. I start at time 0 with $100. So as you can see, time will be written below the axis, just like here. The amount will be written on top of the axis. At the end of year one, at I, simple interest, equals 0.05, we said, you would have $105. What about at time 2? What would you have? 110. So what has happened? What is the rule here for simple interest? What's the rule? Yeah.
You only based off the starting principal amount, it's not compounded based off.
The amount of interest is based on the principal that you began with and does not change from year to year. So the interest, capital I, here was $5, and here I was another $5, and in the next period here, I will be another $5. So you will have $115 at the end of 3 years. Agree? So simple interest means that at the end of the first year, even though you have $105 in your account, it's not the $105 that will be earning interest. It's still the original principal of $100 that is earning the interest. Are you with me? You're going to speak out when you're not with me, right?
Yeah.
Okay. What is compound interest? Let's do the same thing, but this time it's a compound. I, compound, equals 0.05. What do you say? I start at time 0 with $100. What do I have at time 1?
Still 105?
Still 105? Okay. 105. And what do I have at time 2? Yeah?
Whatever 105 times 1.05 is, so the 105 is 1.05.
Okay. Okay. So 100 times 1 plus 0.05 to the second power. Here I have 100 times 1 plus 0.05 to the first power. And here I would have 100 times 1 0.05 to the third power. Are you in agreement? So this compound interest looks like what kind of curve?
Exponential.
Exponential curve, right. Starting where? Where do I begin at time 0?
At the principal now.
Okay, 100. So this curve will look something like this. Agree? That's the exponential function. Does everybody understand why the amount function is the principal times 1 plus I raised to the t power? Does everybody understand that or no?
Is for the third year over there, is that supposed to be 1 plus 0.5?
1 plus 0.5 is how much? How much is 1 plus 0.5? I mean 0.05.
1.05?
1 plus 0.05 is 1.05. Finish, right? That's why I wrote that. No problem. No problem. That's exactly what we need, is for you to speak up instead of just keeping on thinking about that. Now it's done. Okay, so this is my compound interest function. What does simple interest look like?
Linear.
Linear. So let's write here, linear. Okay, what is the accumulation function for simple interest? An accumulation function tells you, let me define accumulation function. A of t, little a of t, is the accumulation function, and it tells you how much $1 has accumulated to at the end of t years. So a of t for simple interest is given by what? Can you tell me the a of t function? I'm starting with $1. I would like to know how much money I have at the end of t years. Can you give me a formula, please?
Principal plus big I times t.
Principal plus
Big I times t, whereas because I was like what you incremented by.
Do you agree with him? He's saying principal plus big I times t. What is big I? How should I define big I?
Well, it was like what you incremented between each values of t, like 5 in the above example.
So how much is big I, uppercase I, in terms of p and lowercase I? You're right. It's not wrong.
Little I times the principal.
Exactly. So p, which is my principal that I began with, plus p times I. We're talking about simple interest. Thank you. Times t. In other words, it's p times 1 plus I t. What am I trying to say here? I'm trying to say that if the interest rate is 5%, simply multiply that 5% by the number of years that the principal has been deposited in there, and add that amount to 1, multiply by the principal. That's what's going on up here. Each time $5, so 0.05 times 100, which is $5. Each time $5 is the increment for every year. So A of t is this. How much does $1 grow in a period of t years? That's A of t, lowercase a of t. That's called the accumulation function For simple interest, this is equal to 1 plus IT. Does that make sense? How much money would I have at the end of 8 years? I would say 8 times 0.05 is 40. 0.4, right? 0.4 plus 1 is 1.4 times 100. 140 bucks. Get it? Okay. What is A of t for compound interest? It's 1 plus I to the t. If I deposit $1 at time 0, at time t, I will have 1 plus I raised to the t power. Why is that formula what it is? Let's talk about that for a minute. Let's start at time 0 with 1. So this money grows at compound interest rate, let's say 5%. So at time 1, I would have 1.05. At time 2, I would have this 1.05 from time 1 now growing at an interest rate of 5%. So couldn't I say this is 1.05 itself, this 1.05 itself, plus 5% on that amount? This is the interest for the second year on 1.05. Are you following me? 5% compound interest on the 1.05 that I began this year with, this second year with. So when I factor out the 1.05, factor it out, you get 1 plus 0.05. In other words, 1.05 squared. That's where this 1.05 squared came from. Are you following me? Let's do it one more time. Year 3. Well, at year 3, for year 3, I began at time 2 with 1.05 squared. That's my initial amount for that year. Plus, the interest part will be 5% of that amount. In other words, factor out that 1.05 squared, and you're left with 1.05. So you have 1.05 to the third power. Get it? Similarly, at time t, you would have 1.05 to the t. That's where that formula comes from for compound interest. Do you have any questions? So this A of t equals 1 plus IT for simple, and A of t equals 1 plus I to the t for compound. Stick it in your mind and hit enter. That's your basics, okay? That's your alphabet. Right now we're just building the alphabet. What is your question about anything I've said? Let's get back to the original notes that you were given. So I'm here on page 1. So it says here, an investor lends money to a borrower with the hopes of financial gains. He lends K at time T naught. Let's label it. Here's time T naught, K. And it grows to S at time T1. Then S minus K is the interest paid back by the lender. Make sense? Moving on. talking about accumulation functions and amount functions. We are interested in tracking the amount of interest gained on an investment over time. Principal is denoted by K. There is something called an amount function, capital A sub K of T, which gives you the balance at time T of an amount K that is invested at time 0. So when you see this subscript of K, it's telling you I'm not starting with $1, I'm starting with K dollars at time 0. And capital A of T will give you the amount at time T when you start with K at time 0. That's called the amount function. And little a of T we just talked about, that's the accumulation function. The accumulation of $1. You're starting with $1 at time 0. How much has it accumulated to time T? At time T. So look at this right here. Lowercase a of T is equal to the amount function for $1. That's how a of T is defined, right? Whenever you talk about lowercase a of T, you're always assuming that you're starting with $1. Okay, let's look at this example. First example. For every $1 that you invest at T equals 0, you gain 10 cents every year for the life of the loan. Therefore, A of T is equal to 1 plus IT. That's the formula I'm using here. It's a simple interest like we talked about a minute ago. There's nothing new here. You can see that I'm multiplying by K because this is little a of T. The accumulation function when you start with $1. So obviously if you start with K dollars, then the amount function would be K times 1 plus IT, or K times little a of T. So I'm saying if you start with $1, you use little a of T. If you start with K dollars, you would multiply by K. That's it. Let's look at the next one. You invest $5,000 at T equals 0. It grows by $250 per year. Find A 5,000 of T. Let's draw it too. This is simple interest, right? Because it grows by a fixed amount per year. Every year it only gains $250, so I can see that this is simple interest. This is going to be a linear function. Let's draw this linear function. I'm going to start at $5,000. This is my A of T. This is my T. And this is a straight line. What is the slope of this straight line? 250. Every year you add 250 to the amount that you have in the account, correct? So A of T, A 5,000 of T, which is what they're asking you for, is 5,000 plus 250 times T. May I ask you to tell me what the simple interest rate must have been in this example? Please find me the simple interest rate. 5%? How do you know? How should I solve for that? Just do what? Okay, so this is P plus PIT. So P times I equals 250. And P is given to be 5,000. So 5,000 I equals 250. Therefore, I, simple interest, so usually that's denoted S for simple interest, is equal to 250 divided by 5,000, which is 0.05. So that interest rate must have been a 5% interest, simple interest rate. Get it? Any question? Let's do the next example. 1,000 is invested at t equals 0 and gains 250 paid continuously per year for 3 years. What is the equation of A 1,000 of t? By continuously, we mean that if you close your account after 6 months, you will earn 6 months interest. What might A of t be here? Can you tell me? A of t equals what? So I should say A 1,000 of t because I'm starting with $1,000. It's not a trick question. It's just more of the same. Can you give me the function A 1,000 of t equals what? It earns $250 continuously, right? So how about something like this? 1,000 plus 250t. It earns this for 3 years, so t less than or equal to 3. And 1,750 otherwise, because after 3 years it doesn't make any interest. Does that make sense to you? Here in this example, interest is not credited at the end of the year. It's continuous, meaning for a partial year you're still earning interest, but it's still at the simple interest formula. Follow me or no? Let's try the next one. To see when AK of t is not equal to KA of t, consider the following tiered interest function. When your account balance is $250 or less, you earn interest at a linear rate of 10% per year. Linear rate. So let me circle that so that I know to use simple interest. Otherwise, you earn interest at a linear rate of 8% per year. K is equal to 100. Can you spend a couple of minutes and try this yourself? I want simple interest. I wanted to pay simple interest of 10% per year when my account balance is $250 or less. If it's above $250, it makes less interest at 8%. Can you come up with A of t? I want you to find me A 100 of t for this. I'm still talking about simple interest. I claim that it's going to be a tiered function. By tiered function, I mean one function for 250 or less, another function for greater than 250. Can you please work on this right now? You should bring your calculator to class every day. How about first we try to find out how many years it's going to take to get to 250? So let's write here, how long to get to $250? So could I do something like this? 100, that's my principal, 1 plus 0.1 t is equal to 250. If I solve this equation, it'll tell me how long it's going to take me to get to 250, right? Let's do it. 100, let's just divide. So I'm going to divide both sides, divide by 100 on both sides, and I get 1 plus 0.1 t equals 2.5. Therefore, 0.1 t equals 1.5. Therefore, t equals 15 years. So it's going to take me 15 years just for my money to be $250 at simple interest rate 10%, which makes sense, right? $10 a year, right? For 15 years. So 100 plus 150 will make 250. Get it? So over here, couldn't I say this? A 100 of t is equal to this tiered function, 100 times 1 plus it, where I is 10%. This is the function for t less than or equal to 15. Make sense? And can you please come up with the function for t greater than 15? What will this function be if t is greater than 15? Can you tell me? Hello? Yes.
Same function, but the interest rate now is 0.08.
The same function? Are you sure?
1 plus 2.
You want to say 1 plus 0.08 times what? Times t? Do you think it's times t? Yes, sir. What do you say? You want to put 250 up here? Okay. Times t? T minus 15. What's going on here? It's not what you originally said, guys, is it? So this one's clear, but this one is saying if your time is greater than 15, then at time 15 you're already up to $250. That $250 has to grow at 8%. For how many years? These many years at 8%. So if t is 20, this would only be 5. 8% for 5 years. You get it, right? This is 250 because you are at 250 at time 15. So you better not be saying 100 there, right? That's too little of a bank balance then, right? If you say 100 over there. If you don't understand this, please let me know. Yeah.
For the linear interest, or like simple interest,
Mm-hmm.
wouldn't it always be P, like in front of the interest rate?
No, because at the end of 15 years, your balance is $250.
Right.
So what is growing?
The amount invested. It might just be the question. It might be, it's otherwise you earn an interest rate, an interest at a linear rate of 8% per year.
Right, so it depends on how you interpret that question. Yeah. Interpret the question such that when
You reach.
you reach 15, you have a balance of 250 in your account.
Okay.
And then it starts earning 8%.
Yeah. Okay.
Yeah, that would have to be specified precisely, yes. Any question?
In the first one, we factored out 100, right? And we got 1 plus 0.1t. And the second one, shouldn't we factor out 250? Or is
We did. This is factored out. 250 parentheses 1 plus 8% for the rest of the time.
right? But isn't it like 8 over 250? No, right? Why? Why is it not 8 over 250?
8% per year
Yeah,
for this many years.
Yeah. Okay.
So the formula is P parentheses 1 plus I times the number of years that the money is invested. So here's the 250 times 1 plus I times the number of years that the money is invested past 15 years. Get it?